Hello again. This is Noji TV. Today we are going to see how can we use Pythagoras Theorem in order to calculate the magnitude of vector R in a space or in 3 dimension, where r squared would be equal to a squared plus b squared plus c squared. We would also see how we can calculate the direction cosines of the angle corresponding to the z-axis, y-axis and x-axis. So don't forget to share this video after watching, and if necessary subscribe if you haven't ever. So the more you visit Noji TV, the more knowledge you will gain. Thank you. Hello again, bakunzi ba Noji TV. Today we are going to see how we can prove in 3D that r squared equals to a squared plus b squared plus c squared, where A, B and C are corresponding to the x-axis, y-axis and z-axis respectively, as you can see them at this figure. And now we also discuss about direction cosines and how it can be calculated. Now let's start. We have to prove that r squared equals to a squared plus b squared plus c squared. Now to calculate this, let's first calculate the magnitude of ON. Now as you can see here, ON squared equals to ON is this from here, from origin to this end here. This ON, and this will be given by AO squared, this one, and plus OB, as you can see, OB squared. Yeah, but here also you can see that AO equals to A and OB equals to B. So replace the value of A and B in the position of OA and OB respectively. So we will get ON squared equals to A, which is equal to A squared, which is equal to OA squared. Now A squared plus OB squared. This OB squared, you have seen that it is equal to B squared, so write B squared. Now at this point we have seen the distance from here to here to the relation. So let's I think if we have this distance from here to here and this from OC here and the ON here, this can give us the magnitude or distance from here to here. I say distance OP, as you can see here, distance OP. Distance OP would be explained or defined by distance OC and distance ON. So let's also prove it here. Distance OP squared, this one would be equal to ON squared, right? ON squared plus OC squared, because it is this distance from O to P, where O is the origin. So we write OC squared. Yeah, but we have seen that ON squared is equal to, as I have right here, is equal to A squared plus B squared. And here, if you look carefully, you have to see that OC is equal to C, where C, it is the coordinate of Z along Z axis. So OC is equal to C. So replace ON squared and the OC squared here with its value. Get OP squared, which is equal to ON squared, which is equal to A squared plus B squared, A squared plus B squared, plus OC squared, which is equal to C squared, because OC is equal to C. Yeah. So from this diagram or this figure, you see that OP is equal to the R, or is equal to R. Yeah. So OP equals to R. So OP squared would be OP squared would be equal to R squared. So R squared also would be equal to A squared plus B squared plus C squared. R squared would be equal to A squared plus B squared plus C squared. Yeah, I think at this point R squared is equal to A squared plus B squared plus C squared, and this is the required answer. So this is required. So but we have asked to calculate the magnitude of vector L. I think this I can say this R is a vector in a space, which has a component A along x-axis, component B here along y-axis, and the component C here along z-axis. So the magnitude of vector L, would be L, which is equal to square root of A squared plus B squared plus C squared. Yeah, because if R squared is equal to A squared plus B squared plus C squared, R only without square would be equal to A squared plus B squared plus C squared. Yeah, I think that is right now. So let's move on. Direction cosines. To prove the direction cosines, we have also to consider the component of vector OP, as I have told you right here. So the vector OP is defined by its component A along x-axis, B along y-axis, Z along z-axis. Yeah. Not Z, it is a C. We have seen C here. C along z-axis, A, component A along x-axis, component Y along, component B along y-axis. Yeah, and that is right. So as we can see here, we can say that cosine alpha would be equal to A over R here, A over R, and also cosine beta here, this angle here, this angle here, beta would be equal to cosine beta would be equal to B over R, and also cosine of theta here would be equal to C, component C, this C coordinate of Z axis, over R, also C over R equals to cosine theta. Yeah. So From here we are going to calculate for A. A would be equal to R cosine alpha. B would be equal to R cosine beta, and also C would be equal to R cosine theta. Yeah. Okay. Then as we have seen here, yeah, but we have seen that R squared is equal to A squared plus B squared plus C squared. Yeah. So if you replace A squared with its value, B with its value, C with its value, you will get R squared, which is equal to R cosine alpha squared plus R cosine beta squared plus R cosine theta squared. As we have seen, R cosine alpha equals to A, R cosine beta equals to B, and R cosine theta equals to C. So I think that is right. So we have also R squared, which is equal to R squared cosine alpha squared plus R squared cosine beta squared plus R squared cosine theta squared. Yeah. This would be equal to R squared equals to R squared plus cosine beta squared plus beta squared plus cosine theta squared. Yeah. So divide R on both sides, so you will get R squared over R squared equals to R squared over R squared cos squared alpha plus cos beta squared plus cos sin theta squared. So we will get 1 equals to cos square alpha plus cos square beta plus cosine theta squared. Yeah. So if cos alpha equals to L, cos beta equals to N, and cos theta equals to N, and replace the value of cos alpha, cos beta, cos theta in this equation, we will get 1 equals to R squared plus M squared plus N squared. So that is what called cosine direction or direction, cosines of direction cosines of vector OP. Yeah, vector OP. And this would help us to know the angle made with x-axis, angle made with y-axis, and the angle made with z-axis. So angle made with angle made with x-axis is color, and that of z-axis is theta here, and that with y-axis is m.